Hello, and welcome to our Defense in Indiana webinar series. My name is Samantha Nelson, and I'm the program manager for the Purdue Foundry at Westgate, which is located within the Westgate Academy in Odin, Indiana, and is directly outside the gates of the Naval Support Activity Center in Crane, Indiana. We here at Purdue at Westgate strive to be a valuable resource and connecting point to the defense industry, startups, small businesses, and academia. Whether you are using us as a place for training, a place for office space, defense event space, supporting startups, or just knowledge sharing opportunities like the one today, we like to think that we continue to support the immense warfighter mission on a daily basis, as probably a lot of you do too. We want the same things you do. We want to help support the regional economy thrive with the hopes of creating jobs and new innovations within the next decade and beyond. Having said that, our Defense in Indiana webinar today will be focused on the power of bad data, and we couldn't be more excited to have Alicia Scott out of the Naval Weapons Support Center, Crane, Indiana, to be presenting today. Alicia is the lead for the data science team within the Systems Engineering Division at NSWC Crane, and she is recognized as a subject matter expert at Crane and within the greater artificial intelligence and machine learning warfare center community. You are welcome to leave your video on if you wish, but we ask that your mics remain muted during the presentation. A copy of the recording of the webinar as well as the slide presentation will be sent to you following. Also, you may ask questions by using the chat function at the bottom of the screen. Alicia will answer correct questions directly after the webinar. Without further ado, I would like to introduce you to Alicia Scott.
Good morning, everyone. I'm going to share my screen. Okay, like Samantha said, my name is Alicia Scott. I work at NSWC Crane and am excited to lead this talk today. This is a discussion on the power of bad data and the opportunities that we have even in a less than perfect scenario. The talk will be about 30 minutes, and then I'll go into questions and discussions afterward. So, like I said, my name is Alicia. I lead a data science team for Crane. I originally started my career in industry working for a market research firm doing statistical analysis and data reconfiguration. I then moved into a more research heavy role at Crane and built from the ground up the data science team that is working there now. We started this growth through algorithmic development, which is where our patents are from. We have a patent for natural language processing for short text data, and then a pending patent with my research teams from cross warfare centers for data pre-processing. My contact info is below if you wish to reach out after this presentation. So we've all seen in the media, in other industries, in the work, the power of data in general. The examples everyone uses of Google, search engines, Tesla's driving car, the banking industry, investment industry. We've seen data implement huge changes across the gambit of industries. Its usage and implementation as a powerhouse has made a huge difference. But we hear a lot about good data and how there must be good data to use that data. I want to kind of hold a discussion about how garbage in, garbage out, the phrase that everyone seems to use, isn't always true, that there is still use even in bad data. Not every business is built in the 2000s, was built on data collection, data integration, and data analytics in their original pipeline. We have businesses that are legacy, that are engineering maintenance based businesses, that kind of pipeline is not attainable in the immediate. It's something that takes a lot of work or overhaul. You can't have the same data strategy as Google if you're not a Google, and that's okay. I argue that bad data is helpful for a variety of organizations. Now, I do want to start off with what I mean by bad data. So I don't mean data that was collected in a way that makes it super biased. I'm not meaning data that is collected immediately with a specific goal in mind. So by bad data, I mean data with holes in it, data that's not got every field collected. I've got data that has changed formatting over the years, data that was collected in a methodology more suited to previous business models, legacy data that's existed for forever. I'm talking about data that most organizations may have built at one time to answer a variety of questions, a hodgepodge approach, if you will, of throw everything at the wall and we'll see what sticks, or we'll collect a lot of things and only answer one question from it. Data that maybe isn't in a perfect kind of environment. So that's what my talk is focused on mostly. There are a variety of cases that are extraneous solutions as well. So my main argument is that waiting for good data to happen, the perfect opportunity for building the perfect data perspective is a sliding timeline. Good data doesn't just happen, and waiting for the perfect opportunity to implement that data pipeline of your dreams is something that can make an organization's use of data take a lot longer. It's something that is a mountain to implement. And seeing something so large, it's hard to break it down into small pieces. And then it also lacks the realization of the benefits that could be had immediately from the data that is on hand. So some of the benefits of bad data, the type that I was discussing, it's often the untapped resource. And it can be a strong asset for organizations with legacy information, and especially the data that's been unedited. So it's not set up with a human element of biases necessarily ingrained in it. So some data in general is better than no data. So even if that data is bad data, you can get something out of it better than if you had no information at all. It often has a longer legacy as well. So a legacy of having a history behind it. There may be a lot there that hasn't been mined, that hasn't been used to its fullest, even if it's not in the best format for usage. And what I mean by having edited out the human element can lead to a lot of findings within that. So some data pipelines in the current models that are out there are built to answer one question or a certain set of questions at the beginning, and so are designed to answer those questions, whereas legacy or older data may not have been collected in that format. And so it's going to tell its own story without being funneled towards answering a single question. So there's more you could possibly get out of it. Now, all that is just doesn't mean that data quality and veracity don't matter. We still care about the 5 V's of data. We still care about the value and the truth behind it. If we're going to work with bad data, organizations and analysts need to have an honest perspective on the state of that data. Bad data can be used as a piece of the puzzle, but it shouldn't be used as the ruling authority. So it can't be the data says this, so it's automatically true. It's vital that we have an honest perspective when we go into this of we need to get the context behind that data if we're going to be able to use it. So there are extra steps that are needed to work with bad data, but I think that they make up for it in the quality or in the benefit that we can get from that data. You need to know how accurate the data is, how full of a picture it represents, and then you can be aware of what good can come of it. Even if it's not perfection or everything you want from it, you can still get pieces of goodness. So working with the present possibilities can lead to a current, future, and success if implemented thoughtfully, as I've been discussing. I often get told if you wait for perfect conditions, you'll never get anything done. So not having a perfect data outlook shouldn't stop you from using the data that you can now. And dealing with the data that you have now can set you up for a future that can build on itself. It sets you up to know the processes now to influence how you implement in the future, how much data matters, what questions you're asking time and time again. It can really influence organizational future projects in a positive way by working with what you have now. I want to go into, for people who maybe aren't so versed in working with data day in and day out, some actual tactical options for dealing with the bad data. What are step-by-step things that we can do to make it easier to work with, or so that we can have a little more validity in our analyses? The first two big ones are data pre-processing and a clear data pipeline. So I really like this visual example on the left. So it starts, a lot of the bad data that we're talking about, you can picture it as like a pile of your child's toys, like every single toy they've ever owned in a single pile. And from that, you want to get the things that you actually care about. So in this case, you care about the Legos. So you pull out of that giant amalgamation of toys, all of the Legos. So you've sub-collected data. You then sort that into the various colors. And then from there, you make the stacks for arranging the data. So that coincides with like a grab anything and everything approach, a continuation approach from our legacy data. So if you have a keep everything, hold on to everything, you then pare down to relevant information or grab a subset from the source data. Then the hardest part, in my opinion, is the sorting and the cleaning portion. The 60 to 70% of your time, or the make or break point. The decisions you make in this context can affect what you see in the analyses, can affect the results and the trends that are viewable in the data. And then the final step is arranging the data, aligning for a specific purpose, formatting, and the pre-processing to answer the questions that you want to answer, to be able to run statistical models or AI on that data. Bad data does rely heavily on data pre-processing and a clear data cleaning pipeline. I would suggest implementing a standard data cleaning pipeline when doing this. Now, a data cleaning pipeline can be very, very general and probably should be. Often we see with our bad data that they're all very disparate sources, so they all need treated very differently. So having a general data cleaning pipeline of we do step A, B, and C every single time, and then having more point solutions for data pre-processing, which is something that's more unique and tailored to each individual data set. Another option for tactical responses for bad data are using raw data findings to prompt further analysis. Like I've been saying, you use the findings as one piece of the puzzle, and then you're backing up those findings with the full context. So the image that you see below there is a standard heat map that we had on one of our analyses. I've cleaned out all the labels so that you just see the numerical picture. In those numbers, the point solutions I'm talking about are the dark blue sections. So those points are oddities. They're not following the standard pattern of the rest of the data. So those are maybe trends or pain points that we would want to look into further with analysis. So maybe look at those numbers in an analytical context and then bring them to a real life perspective of, let's see if there was a reason for this happening in our actual business processes, or if this is a real trend, not just a one-off that we should be looking into and changing. So those raw data findings, those trend points or outliers can be an immediate way to implement a pretty simple analysis from your bad data. So I want to talk a little more about using good data tools for bad data. So often we hear that you can't implement analytics or AI because, again, garbage in, garbage out is the phrase that everyone loves to use, that if you put in bad data, you're going to get bad results that don't actually apply. I'd like to argue that there are ways, if you go in with your knowledge that it's not a full picture, to implement these. And analytics is a fairly easy one. There's still a data story hidden in imperfect data. And like we discussed before, there might be more story there than in a perfect data pipeline. It's still, you're still able to find relationships and correlations, and they may even be easier to spot in bad data because it's not been designed to answer a specific question. So you may be able to see more pinpoints in something. Potential unfiltered and unique perspectives into data trends also, because it's not in a standard pipeline. Uncurated data, while more difficult to work with for sure, has not been designed in a standard structure and often has more information contained within it. Now, I really want to focus on how you implement AI for bad data. I want to caveat the whole discussion that it has to have a larger focus on trust and verification. Implementing trust and verification into your AI is imperative with bad data. You need to know why the AI is making the choices that it is. And you need to be able to explain the parts of the process for successful implementation of verification for the AI. Again, I'm hitting back on the garbage in, doesn't have to be garbage out. You can recycle that bad data into insights and ideas for your organization that can actually move things forward. Now, if you're new-ish to AI, I would not suggest starting with neural networks for data that isn't in good working order. I wouldn't suggest using artificial intelligence that has the quote squishy layer, where you can't explain the pieces of the puzzle and why they fit the way they fit. And I think a neural network is generally a little bit more difficult to implement in that vein. So here are some easy ways to dip into machine learning for bad data. So one of the ways we use is using machine learning as a prompt for deeper analysis. It pinpoints trends or clusters in the data for a more rigorous statistical analysis to confirm. So like the heat map here, you've seen a similar heat map before, being able to pinpoint those trends of this might be something to look further into. We also use machine learning to fix issues in the data. It depends for sure on the reliability level of the original data, but we can use ML to make our data perspective better than it is with our current resources. Another way is using machine learning or algorithmic coding to reformat or populate data in a new way. So this includes automation, storage, data pipeline. Automation is a way for an organization to see pretty quick ROI. So automating manual processes or repetitive tasking is a way to use your data to really empower your organization in a fairly short order kind of way. Natural language processing is the form of AI that we have found the most success in for our quote bad data. So NLP, for those who don't know, is the process of having a computer understand human language or human speech patterns. So it relates concepts through language or linguistic trends. Ways you would have seen this are Alexa, Siri, Google auto-completing your search results. Any kind of voice to text is a type of NLP. And now we take this broader concept into a much more focused version. We take short text or text within a data set that may not be perfect, may not be perfectly clear. A lot of our legacy data tends to have a text component that is often not used to its fullest because it's very difficult to process. So we're able to pull a more detailed picture through mining that text data. NLP has really become a powerhouse for us for processing our quote bad data or our less than perfect data. There's so much hidden in that text because there's a human element of being able to fully explain something. And because it's difficult to process in a manual way, it takes a lot of time, a lot of investment. We're finding a lot of immediate return by implementing natural language processing on these text bases to find quick findings and quick results. We're also able to find a more, quote, unbiased result in our NLP. So we do this because when a human is reading something, they're automatically looking for a certain type of answer. So in the context of a maintenance failure, you're looking for a part that broke. Whereas an algorithm doesn't have to be trained to look for a specific type of answer. It's just looking for a generality depending on your training. And by using that factor, you can find cross trends on the data that wouldn't be easily seen to the human eye because we already have context going in. So the unbiased results have been able to really move our analytics forward in my team. So I'm going to go into good data practices in a bad data world. There are practices for good data that can be immediately implemented with bad data that, while not maybe perfect, can really move things forward. One of these is creating data pipelines that enable the organization. So having an established pipeline allows for better organizational alignment. Everyone's on the same page. It allows for an organized chaos. Yes, the data pipeline may still be chaos. There may still be lots of disparate sources or silos, but having an established pipeline can get more people on the same page. It also allows for improvements on small pieces of the pipeline at a time. As we discussed before, overhauling an entire data pipeline can seem like an insurmountable task. By having it broken out into steps, you're able to take small pieces and implement change over time. So you're able to move yourself towards a good data future with more ease because of it. Strong data processing strategies and standards are also being able to be implemented on bad data. Having an established process for cleaning, reconfiguration, and batching are necessary even for good data, but for bad data can make for a more unified analytics approach as well as many other benefits. It can smooth out your processing, it can smooth out your standards so that the organization can be on the same page. And then using data to influence organization decisions, as long as you have the context to back it up. Understanding the data you have now can help you flag changes or issues in the future. It influences your perspective on what the organization needs to spend on. It also, by implementing now, can show you how important data is in your future as new programs are starting up. You're able to implement those changes that you saw on the back end. I'm going to go into lessons learned from my experiences with bad data. I'm going to hit these fairly quickly, but I'm happy to have further discussion, or if there's questions after the fact, you're welcome to email me about them. So some of my lessons learned are how much a good data pipeline matters regardless of your data quality. Legacy data and a storage plan are important to a full data perspective. Throwing out data or not planning for storage at the beginning can really be a pitfall, or can keep you from even further perspectives that you'd be helpful to have. Given the opportunity to set up good data processes, it's almost always worth it to do so. And it's way easier to enable good data at the onset of a project rather than trying to fix it after the fact. So as you're building new projects, you're building new programs, planning for data at the beginning makes a large difference. So while we have power in our bad data, if we can have good data, it's better to do so. For such a powerful tool, data is often underfunded and underplanned for in new projects. It's often the afterthought, or we'll deal with that at the end when we actually care about the analytics. But if you're not planning for that at the very beginning of your project, it's harder to implement that going forward. Or funding for its legacy, its storage, its analytics, its implementation isn't thought of at the onset and can become a pitfall for new programs. There also can be a disconnect between people that are inputting the data, who are hosting the database, and the analysts who are processing that. If a perspective can be used to come together in collaboration at the very beginning of a project, the project tends to have more success. And having communication between all 3 points of the process tend to make it better. You tend to have better data on the input side. You tend to have a database that works better for both the people inputting the data and answering questions from the data. And analysts are more aware of the perspectives of those that are inputting the data as they're doing their results. They're not just seeing numbers, they're seeing realistic solutions and real life occurrences. Bad data can be used to make insightful and impactful decisions as long as the proper precautions are taken, and those must be taken. So again, data integrity does really matter. So understanding, as the wheel there shows, understanding where your actual data reality is, how accurate, how complete, how consistent, and so on and so forth. So being aware of that when you're going into bad data, so that it reflects on the end of your analytics. So double checking findings and making sure that you have the context behind make a big difference. One of the biggest things we've seen is that bad data provides a challenge for our analysts and our scientists to have a better understanding of data in general. It makes it more aware to them how important a good data pipeline is. it also makes it where they have to understand that data backwards and forwards. There is so much more that goes into breaking down a data set if it's not organized at the beginning. We found that for our new employees, working with bad data can make a huge difference in their onboarding and how well they take to analyses in the future. And it helps them in their own as they're planning, whether that's with programming, with automation, with statistics, or with output and communication. By working with data that's less than perfect, they are able to make a huge leap that would have taken years with standard practices because they never would have encountered that sort of thing before. So we found it's a good learning lesson for them. I'm going to go a little bit into the actual toolkit or tools that my team uses day in and day out when we're doing analyses. So standard open source tools were often built to work with good data or perfect conditions. We didn't have those in our data, so we built our own tools. Now we utilize maybe certain libraries or we utilize pieces of the puzzle, but we often have had to kind of rely on our own strength there. We have a machine learning toolkit, we have various AI tools, automation tools, that kind of thing, but I'm going to focus on 3 specific tools as I'm discussing through here. This was mentioned earlier. We have a patent pending from our research group here. This was data pre-processing with machine learning and natural language processing. This was a cross-warfare center developed algorithm. We created a modular and agnostic algorithm for data cleaning, data transformation, analytics, and artificial intelligence solutions. So the goal of this was for analysts and researchers to mitigate the current issues of spending up to 80% of their research time on data wrangling. It also brings AI to a more accessible level. It's more of a point and click AI implementation for those that are working with data a lot, but maybe don't have that programming background. What's nice about this program is the modularity and the agnosticness. So it's not built for one single source or type of data. And you can also self-select in and out any of those modules. There are about 25 modules all told, crossing the gambit. You can also run data through it multiple times for changes in what your needs are, whether you're more focused on analytics at the time or AI solutions. The next one I want to discuss is the other patent that my team has, which is NLP for reliability. The goal was to solve the labor-intensive process of mining failure records. So we developed an in-house algorithm to do that, but we developed it again in an agnostic fashion because we didn't want it to serve only one purpose. We wanted to make it cross-useful. So it's able to automatically identify trends in text data. So like standard NLP practices, it deciphers plurals, parts of speech, different capitalizations, and then it maps linguistic use of words to identify commonality. What's nice is that it's scalable and multi-use. So it can work on small to very large data sets with no changes necessary. And then it's not built for one type of data. It can be edited or used on any sorts of trended data to find overall themes throughout it. And then the current research project that my team has right now is ARISE, which is an automated recommendation investigator. This was again a cross-warfare center developed program between NSWC Crane, NSWC Corona, and NSWC Port Hueneme. They work together to create a topic modeling tool that utilizes NLP and machine learning to establish likeness in disparate maintenance or failure records. So by this, I mean it is able to look at a database and group the various results into clusters, or these are similar failure types or failure causes. And then it's able to compare a new failure entry against those to automatically suggest a solution of, we've seen this failure before and here's how it was solved before. So it can automatically solve failures for our maintainers on the front end. It's scalable and is able to also group while also giving actions and recommended steps forward. So in conclusion, waiting for perfect data isn't viable. It's not an option for most of our organizations. We want to use the benefits that we have now. Bad data still has plenty to offer, and in some cases, even more to offer because it's not been overly sanitized by developers at the beginning. AI and data science tactics still have their place with bad data. It's not always true that it's garbage in and then garbage out. There are good data practices that can be implemented even in bad data. And learning with this to work with the situation you have now can enable your team and your organization to be more impactful going forward. I want to thank you all for your time and for listening. I'm open to questions and discussions now.
I don't see any questions in the chat function. If anybody would like to ask a question, we'll be on for just a couple more minutes. Like to go ahead.
Oh, hi. I was just curious, and you don't have to go into great depth, but just what are some of the NLP techniques you used and some of the tools in that area?
Yeah, we tried to take NLP to not something crazy complex. We wanted it to be as simplified as possible. So we started with parts of speech tagging and found that aggregating across that was really helpful. And then mining the patterns that we often saw across. So you have text patterns, you have linguistic patterns, you speak in a similar way. And by mining that pattern of speech, you're able to pull out trends easier. So it was really analyzing language and how language works and then transferring that to a computer system.
Okay, cool. Do you do anything with like transformers? You said, and it was wise what you said, you shouldn't immediately go to neural nets, but I was just curious as to if you had used some of that in your work.
We've used it a bit, but we try to be very careful on the context that we use it for. It's harder to use bad data. So we have been using neural nets after cleaning the data and putting it through a pretty rigorous data preprocessing.
That makes sense. Okay, thank you.
Thank you.
I do have a question, Alicia. In your data pre-processing section, could you discuss the 60 to 70% comment?
So we end up talking with a lot of different researchers as we go through workshops or research events talking about our various work. And so many of them, to try to implement AI or analytics, were spending 60 to 70% of their time getting data in the right format for what they needed. So having to clean it up, get it perfect to work in certain algorithms. It doesn't always take that much time depending on your data setup. But we find that that's the largest percentage of time used in getting data ready to make decisions on, to do analytics, especially with AI.
Okay. Someone wants to know more about the NLP. Can you look at old files, Word or PDF, and organize those? And what would it look like as an end product?
So with different algorithms will have different end products. So if you start with like a database, you're going to have a database format. What we've used for Word documents or with PDFs, we write a separate pre-processing script that pulls the text data out of those original documents to map it into a structure that's easier for us to mine. But output could look like a Word document paragraph as a summary, or it could look more like an Excel file where you have results in cell-based kind of answers, like a top 10 kind of thing.
Okay, great. Good questions. Thank you. So I will send a copy of the recording, or we will send a copy of the recording and the presentation to you all. And within that, we'll get a proper contact information for Alicia so that you can potentially reach out to her with future questions. So Alicia, we want to thank you for participating in this webinar and providing all of the useful information that you did. It was a great and interesting, very interesting to me webinar. So everyone can also go to our Westgate, www.westgate-academy.com, to see what our future webinars are, as well as our past webinars. We have them separated specifically by defense in Indiana too, if you want to look at those directly. We want to say a special thank you to IN3, Indiana Innovation Institute, as they are our sponsor for our April webinar series. So IN3 is a vital organization to this region and state and even surrounding states, as they create a hub of national security innovation that helps solve critical defense problems. Make sure you also visit their website at in3indiana.com to learn more about them. So we hope you enjoyed today's presentation. We look forward to potentially meeting all of you in person in some shape or form in the near future. So reach out to us if you have any questions. And again, Alicia, we appreciate you coming and doing this. So hopefully everybody have a great and safe week. So we'll talk to you at some other time in the future. Thank you.
Thank you all.